Okay, we're going to stick with this idea of using inverse operations to solve equations. And today we're going to be talking about solving basic cubic equations. So in the last section we talked about solving quadratic equations. Now we're going to talk about solving cubic equations. Quadratic equations, remember, weird word that means square. So we're talking about equations where the highest exponent is a square. When we're talking about cubic equations, you might be able to guess it's equations where the highest exponent is a 3. Highest exponent would be a 3. So if we take a look at the warm-up question here, again, we're going to be doing things like this for quite a while. Let's go ahead and solve this, and let's not use a calculator for this. I know the numbers might look ugly, but let's see how this works out. We're going to isolate the variable term here by moving that 10 to the other side. We'll do that by adding 10. So we end up with 3x squared, and then over on this side we get a 75. We're going to further isolate the variable by dividing both sides by 3. That'll be the inverse of multiplying by 3. Those will cancel. So we end up with x squared equals, and then on this side we end up with a 25. So let's see, now we've got that square perfectly isolated. So now we're going to take the square root of both sides, and we're going to get x is equal to, remember, before we think about the number, throw that in our calculator. We're going to put that symbol, that plus or minus symbol on there, and then we're going to get the square root of 25, which is 5. So there's the answer. Now it does say check your answer by substituting back into the equation, or remember, that means plugging into the equation. So I'm going to go ahead and write down that equation. So 3, and then I'm going to put a set of parentheses where we're going to plug in whatever x is, and then subtract 10. And then what it's supposed to equal is it's supposed to equal 65. So the first thing I'm going to do is I'm going to plug in a 5. So I'm going to put a 5 right there. This is going to be 3 times, if we do 5 squared, that would be 25, and then we're going to subtract 10. 3 times 25 would be 75, and 75 minus 10 is 65. Okay, so that one checks out. Now the cool thing is, all we'd have to do to check the other one is let's just put a negative on it. So if we put a negative on it, negative 5 squared, well, a negative times a negative is a positive, so we get right back here to 25. So the rest of this is the same. So both of those check out. So perfectly good answer there. And then on part B, it says complete as much of the following table as you can without using a calculator. Now, I am hoping that you recognize this, and I'm hoping that you've done your homework because you really need to have these memorized. Now, I have the entire list on both of these, so you don't have to have all of these memorized, but you do need to have at least down to here and at least down to here. Okay, and remember, even if you don't memorize the ones down below, you should be able to kind of recognize and say, okay, I remember that was on my list. So if you want to pause this or follow along with me, or skip ahead until this is done, if you know you've got to memorize, that's great, but you definitely need to have these memorized, and I'm going to do them in a specific order. So I'm going to do 1 squared is 1, which means the square root of 1 is 1, so we're right back to where we started. 2 squared is 4, so the square root of 4 is 2. 3 squared is 9, so the square root of 9 is 3. 4 squared is 16, so the square root of 16 is 4. See how we're going right around in circles because these are inverse operations? So I'm just going to continue going through here and filling these out. So 7 squared is 49, so the square root of 49 is 7. 8 squared is 64, so the square root of 64 is 8. Just going around in circles there. Okay, and of course 10 squared is 100. 100 square root of 100 is 10. 11 squared is 121, so the square root of 121 is 11, and we get 144 here for the perfect square of 12, so that means the square root of 144 is 12. I'm going to jump over here and do these really quickly. 1 cubed is 1, so that means the cube root of 1 is 1. 2 cubed is 8, so that means the cube root of 8 is 2. 3 cubed is 27, so that means the cube root of 27 is 3. 4 cubed is 64. Again, that's one of those that's on both lists. So that means the cube root of 64 is 4. And 5 cubed is 125. So that means the cube root of 125 is 5. So again, notice how we're doing something to that 5. We're raising it to the third power. Then we're taking the third root of that, and we get back to 5. So 13 squared, 169. 14 squared, 196. 15 squared, 225, 16 squared, 256, 17 squared, 289, 18 squared, 324, 19 squared, 361, and 20 squared is 400. So we can go ahead and fill each one of those numbers in over here underneath the square root, because that square root is going to undo each one of those squares and get us right back to the number that we started with. Let's see, 361 and 400. And then again, we're going to cube 6 and we get 216. So when we take the cube root of 216, we get back to 6. This is 343, so that's 343. This is 512, so that's 512. Let's see, 9 cubed again. That was, some of these are tough to remember, 729. So that means the cube root of 729 is 9. And then 10 cubed, remember 3 zeros on there, so that would be 1,000. So that means the cube root of 1,000 would be 10. And a little extra one on here. Notice the little squiggly equal sign, so that would be approximately equal to. We're going to take a guess. It's just going to be a little bit more. Maybe we guess 10.1. It may or may not be that, but we just want to get close. So that's just a good guess. Okay, so I'm just going to write estimate. Okay. All right, let's see if there's anything else. Down at the bottom, there's some thought questions, and this is going to lead into what we're going to talk about today. Question here is, what is the square root of -4? Now, we talked about this. Square roots are asking a question. They're asking, what number do you square to get -4? Well, let's think about that. If you square a number, no matter whether it's positive or negative, you've got 2 positives, that would equal a positive, 2 negatives, that would equal a positive. Okay, so I'm going to write this down. I'm going to write DNE, and if you haven't heard that before, that stands for does not exist. Okay, so for the time being, we're just going to write DNE, does not exist. Okay, next question. What undoes squaring? And again, the answer is not square rooting. Please make sure you say it the right way. So let's write this down. Taking, or we're just going to say take the square root. Take the square root. So the thing that undoes squaring is taking the square root. So by the same token then, what would undo cubing? Well, if you undo squaring by taking the square root, let's undo cubing by taking the, you guessed it, the cube root. Okay, now you can go ahead and flip the page over, and we're going to make a list of the inverse operations that we know right now. Now remember, operations are things like adding and subtracting, multiplying and dividing. We know how to deal with exponents a little bit now, and then we're going to list one other here, and I've got a hint for that one. So I'm going to write down add, subtract, multiply. Okay, I'm going to put a dot there for multiply. I'm going to put the line with the arrows there. And then these are pretty easy. The inverse of adding is subtracting. The inverse of subtracting is adding. The inverse of multiplying is dividing. The inverse of dividing is multiplying. Okay? Now, the other ones that we've done, two of them deal with exponents. So I'm going to write this down. I'm going to write down that we squared something. Okay, so if we take something and we square it, then we would take the square root to undo it. If we cube something, because we've talked about cubing, if we cube something, then we would take the cube root to undo it. So each one of these undoes each other. This is a double arrow down the middle here. They go backwards and forwards. Okay, so if we square something, we can undo it by taking the square root. If we take the square root, we can undo it by squaring whatever that answer was. Okay, and then the last one, these are kind of inverse processes of each other. One starts with a D and the inverse starts with an F. And if you had me, I know I talked about this, and I know we mentioned this in this class just a little bit. This is distributing, okay? And then do you remember what its inverse is? Sometimes I call this the math F word because it is a tough thing to keep track of. A lot of people struggle with this. It's called factoring. Okay? Factoring. So factoring and distributing, really important skills, but this is kind of a list of all the inverse operations or inverse processes that we've learned so far. So let's take a look at example 1. It says solve the cubic equation using an inverse operation. So again, this is called a cubic equation. So we're going to write the word cubic here because the highest exponent is a 3. Now, do you remember why we called this cubing instead of raising it to the third power? You could say raising it to the third power, but we usually say cubing. Here's why. Remember, if we've got a perfect cube number, that means we can make a cube out of it. Okay, now we're going to go ahead and answer this problem, and then I'll fill this in a little bit more. So we've got a x cubed here. It's isolated and everything. We just need to get rid of the cube on there. So we are going to take the cube root of both sides. Now, one thing a lot of people forget is they forget to put the little index there to show everybody we're taking the cube root, not the square root. Okay, again, notice up above when we wrote down the square root, we don't put an index in there. Everybody gets to assume that it's 2. If we want a cube root or a fourth root or anything else, we have to put that index there so everybody knows what root we're finding. So we're going to take the cube root of both sides. Taking the cube root of a perfect cube of x, those two undo each other, so we get right back to x. And then this is asking what number do we cube to get 8, and the answer to that is 2. Now, a common question here would be, well, hey, on those other ones we could use -2. Could we use -2 on this one? Well, let's check and see. If we plug in a negative, it's going to be 3 negatives multiplied together. So 3 negatives multiplied together would work out to be a negative. So the answer to that is no. We only get one answer to these, not 2, not 3, but just 1. Okay, so please notice that when we're solving these, we don't need a plus or minus symbol. And here's the reason why. When we cube a positive, we get a positive. And when we cube a negative, we get a negative. So when we were simplifying cube roots before, whatever was underneath the cube root, whether it was positive or negative, if it was positive, it worked out to be positive. If it was negative, it worked out to be negative. So let's keep that in mind as we do these problems down here. But before we do that, I'm going to come back and take a look at this. This is why we call 8 a perfect cube. Because if I take 8, and remember the answer was 2, I'm going to make a square that's 2 on each side, and then I'm going to turn it into a cube that's 2 cubes deep. So this is 2 here, this is 2 here, and this is 2 here. And if we found the volume of that little box, that little rectangular prism, that little cube, 2 times 2 is 8. So again, that's the reason why we say cubing more often than we say raising to the 3rd power. So let's take a look at these problems right here. Gosh, some of these look pretty nasty, but we'll get to those. So let's take a look at x cubed equals -1. The cube term is isolated, so we're going to take the cube root of this side and we're going to take the cube root of this side. So we end up with x on this side. Again, no plus or minus. To figure out what sign the answer is, we just look at the radicand, the thing underneath the radical. If it's positive, the answer is going to be positive. If it's negative, the answer is going to be negative. So I'm going to put a negative here, and we're going to put a 1. Now, just for the heck of it, watch what happens if I plug this back in. -1 cubed, does it equal -1? This would be -1 times -1 times -1 equals -1. It checks out. Works perfectly. Okay? All right. Let's see. Take the cube root of both sides because it's already isolated. So we get y on this side. Notice that that's positive, so the answer is going to be positive. And do you recognize this? If you recognize it and have it memorized, great. If not, take a second to think about it. Maybe flip over to the other page. Refer to that list of perfect cubes. That is actually a perfect cube of 6. So the cube root of 216 is 6. Take the cube root of both sides here. Make sure we get that index in there. So we put a z right here. Notice that it's negative. And then do you remember what the cube root of -64 would be, or just the cube root of 64? It's going to be 4. Okay. Again, really nice. These go very quickly, but they go much faster if you've got those perfect cubes memorized. So let's do this one right here. We're going to isolate that, so we're going to add 375 to both sides because that's the inverse of subtracting 375. So we get 3n cubed on this side and we get 375 right here. We're going to continue getting that variable by itself by dividing both sides by 3. Let's see, if you had $3.75 and divided that among 3 friends, I'm hoping you can do that without a calculator. But again, if this were a test question, by all means, grab a calculator. You're going to end up with 125 here. So we've got a n cubed, so we want to undo the cubing, so we're going to take the cube root of both sides. We get an n on this side. That's a positive, so the answer is going to be positive, and the cube root of 125, that is one of those that I asked you to have memorized. So that would be n equals 5. And let's take a look at this one right here. Notice that this isn't quite by itself. There's a negative in front there. So the first thing we're going to do is we're going to divide both sides by -1, or we could just change each one to the opposite sign. So let's see, how many zeros do we have there? Yeah, this is 1,000,000. Okay. All right, so we're going to take the cube root of this side and we're going to take the cube root of this side. Now, we're probably going to grab our calculator on this one, but I'm hoping that you can think about this for just a second. Take a look at how many zeros there are. There are 6 zeros. Okay? I want you to think about how many answers there should, or how many zeros there should be in the answer. Now, I am going to pull up a cube root, so we're going to, again, we're going to hit the math menu. It's the fourth one down. We're going to put in a 1 followed by 6 zeros. Okay, double check, make sure we've got the right number of zeros. Always a good idea to hop outside there, and we end up with 100. So the answer on that one is 100. Okay? All right. 6 zeros to begin with, only 2 here. Remember, we're talking about groups of 3 here, so keep that in mind. That might be helpful down the road. And then on this one right here, so I'm going to add 50 to both sides. So that's going to give me 14m to the third, and then over on this side, let's see, that's going to be 378. 328 plus 50, yeah. Okay, so then we're going to divide both sides by 14. So we're going to get m cubed equals, let's see what we get here, 378 divided by 14, 27. Okay, so after all of that, I'm hoping that's a number that you recognize. So we're going to find the cube root of both sides. This cube root undoes cubing right there, so we get an m, and that's a positive, so the answer is going to be positive, and the cube root of 27 is 3. So we're going to go ahead and circle that, and we are all set to go. Good luck on your assignment.